Welcome to qnawire.
This question, we have a mechanism that's being used on the machine for the manufacturing of a wire product. So over here, we have link AB that's rotating at 5 radians per second. And then because of this rotation, we expect BC to rotate this way. Okay. And then F will be pushed to the left. And then at the same time, while BC is rotating counterclockwise, so C will also be rotating counterclockwise in this manner, and then D will also be this. C and D are two gears, and then because of the motion of C, D will be rotating clockwise, and so DE will be rotating clockwise, and then so we expect there'll be some horizontal component and some components of velocity at point E. So in this question, we want to determine the velocity of point E at the instance shown. Okay. So we are given that omega AB is minus 5k. Okay, and then yeah, so to do this, we are going to start from point A and go to PB, then C, then D, then E. Okay, so yeah, and A is fixed, so we can find VB to be is equal to omega AB cross RAB. Okay, it's minus 5k cross the RAB is 0.05, so the lengths are written down here. Okay, and then the position vector of B relative to A is 0.05 minus cosine 45 degrees I minus sine 45 degrees J. Okay, so doing this, we get 0.25 times 1 over root 2, and then we have so minus k cross minus I, we get plus j, and then minus k cross minus j, we get minus I. Okay. Then we can find VC. Okay. VC is equal to VB plus omega BC cross the position vector of C relative to B. Okay. So 0.25 divided by root 2 minus I plus J. So yeah, so from the diagram we see that VC is going to move to the left. So this is something that we can write. And then for the omega BC from the diagram is counterclockwise. And then the position vector of C relative to B is 0.2 minus cosine 45 degrees I plus sine 45 degrees J. Okay, so we do the cross product. So we have 0.2 omega BC divided by root 2. K cross minus I is minus J. K cross J is minus I. Okay, so this is what we get. And then we group the like terms. Okay, we have 0.25 over root 2 plus 0.2 omega BC over root 2 minus I, and then plus 1 over root 2 0.25 minus 0.2 omega BC J. Okay, So comparing components. Okay, so we start with the y component because we can obtain omega BC straight away. So omega BC is 0.25 divided by 0.2. So this is 1.25 radians per second. And then for the x component, here we can see that VC will just be 1 over root 2, 0.25 plus 0.2 omega BC, which is 1.25 as obtained earlier. So this is 0.354 meters per second. Okay. Okay, so omega C is going to be 1.25 K radians per second. Okay, so recall that this is our gear system. Okay, C and D. So C is rotating this way, so D will be rotating this way, clockwise. So omega D will be given as 1.25 K radians per second. And then we have VD is equal to VC, which is minus 0.354 I meters per second. Okay, so then we can find VE to be equal to VD plus omega D cross RE relative to D. Okay, so minus 0.354 I plus minus 1.25 K cross 0.05 minus cosine 45 degrees I plus sine 45 degrees J. Okay, so this is equal to minus 0.309 I plus 0.0442 J. Okay, so the cross product, if you do it properly, you get 1.25, 0.05, 1 over root 2, I plus J. Okay. Okay, so the magnitude of VE. Okay, is the sum of the square of the components and square roots. So 0.309 square plus 0.0442 square root. Okay, this is 0.313 meters per second. And then the direction of VE. Okay, so this is equal to arctangent 0.0442 divided by 0.309. This is 8.13 degrees above the horizontal to the left. Okay, meaning it's pointing. Okay, so it's pointing this way. Okay, and this is angle theta. This is our VE. Okay, so the final answer for this question is this. Okay, and that's all for this question.